Okay, so we're going to look at now is resultant force. So let's say we got this car, okay, and we apply a force to it. If we just apply one force, then this thing will accelerate. Okay. However, if we apply equal opposite forces on the same line, in other words they'll go through each other, then this thing will either be stationary or will continue at a constant velocity. Now this is Newton's first law. Okay, so essentially an object that has balanced forces will either be stationary, stopped, or it will continue at a constant velocity. However, if we have this one here, so we've got, let's say, 100 newtons on one side and 50 newtons on the other side, then this thing will accelerate because we have an unbalanced force. This is Newton's second law. Now, which way is it going to accelerate? So this is where you do vector addition or subtraction, which we'll look at another topic, but essentially this one is the larger one, so it's going to head off this way with a size 50 newtons. So we could do that with many forces. So we've got two forces this way, 60 newtons, 60 newtons. We've got one that way, two that way, 100 newtons, 100 newtons. We know that this thing is going to now accelerate to the left with a size of 80 newtons. Now Newton's second law also tells us that the size of this acceleration is proportional to the force. In other words, double the force, you have 2 times the acceleration. And we also know that acceleration is inversely proportional to mass. So if in this case here we keep the same force, but we now have 2 times the mass, we will have half the acceleration. Okay, so what we can do is combine these, and effectively you get acceleration equals force over mass, or most common way of writing it, F equals ma. So for example, a guinea pig of mass 1 kg sits on a skateboard of mass 2 kg. If the skateboard is pushed and accelerates at 4 meters per second, how big is the force pushing it? Okay, so that's part of your mass, that's part of your mass. So total mass equals 3 kg. Acceleration is equal to 4m over s squared. So using the formula F equals ma, 3 times 4 equals, and what is the measured in? We're looking at newtons for force. If you apply a net force of 3 newtons on a 100 gram box, let's look at how you can get a net force of that. If I had a 10 newton force this way, then to get a net force or resultant, then I should have something like 7 newtons that way. And so the net force is 3 newtons. And you can do that in any way. You could have 13 and 10, or something like that. Should put this into kgs. Okay, so we're going to have acceleration equals force divided by mass. So 3 divided by 0.1 equals something. What's the unit? M over S squared. Make your own, or you could do something like this. Let's say we had a brick wall. You were running along at 66 meters per second. Okay, and when you collided with the wall, you took 0.01 seconds to stop. Okay, so the first question is, what is the acceleration? Okay, so remember it's change in velocity over time. So we're going from 0 to 6. Going from 6 to 0. And the time is 0.01. You can work that out to get the change in acceleration. And then put that into a F equals ma to find the force. Now, we're missing something. Let's say the person is you, so let's say you're 60 kgs. What is the force? Now the last thing we'll look at is circular motion. Okay, so we've got some angry llamas, 2 of them. Okay, but in fact it's 1. This one is at time equals future. This one is at earlier. Okay, so it's going to start off there with a certain velocity and end there after a certain amount of time. This thing has travelled in a circle. Now, this speed is not going to get larger as you go around the circle. So in other words, if you're sitting in your car looking at not your car, but your parents' car, looking at the speedo, it's staying at the same value the whole way around. Okay, so now the important thing here is the definition of velocity. Velocity is change in displacement over time. Now, important thing about it is displacement depends on direction. Okay, let's write all that down. So velocity, change in displacement over time. Displacement depends on direction. Now, we might not be changing the magnitude, but we are changing direction. So, we must be accelerating. Okay? So we have a change in direction, which means there must be a change in velocity, and because of A equals change in V, that's a triangle, change in V over T, then there must be a change in acceleration, or there must be an acceleration. So must be an acceleration, okay, because of that change in velocity. Now because you have a acceleration, let's look at this formula, F equals ma. If that A is above 0, we must have a force above 0. So there must be a force to change direction. Now, you need to write all that down because that's pretty important. Okay. So because we have a change in direction, there must be a change in velocity, which means there must be an acceleration. Because there's acceleration, there must be a force. What does all this tell us? Let's have a look. Now, going around constant speed must be a force. That's what we've got. Now, we can't actually have any force pointing in the direction of the velocity. There can't be a force applied to the llama in that direction. Because if we did, we would actually make the llama go faster. We would see the speedo increase. But we don't have that. Okay, the speedo stays the same. So there can't be a force in the same direction. And all you have to know is that the force is perpendicular to the motion at any time. In other words, it is always towards the center of the circle. Now because of that, force and acceleration are also in the same direction, so the acceleration is also towards the center of the circle. Now those have special names, okay? The force is called centripetal force or centripetal, and the acceleration is called centripetal or centripetal acceleration. Now, you might have heard the term centrifugal. That is an imaginary force. And we'll talk about why in class. So do not write that down, just centripetal.